Hello, Algebra 1. Today we are continuing with Unit 2. We are on your Unit 2 Day 2 notes in your blue packet, and we are talking about numeric and algebraic representations. So we have quite a few learning targets that we are going to be getting to today. We're going to work on identifying dependent and independent variables, and also some new ones, writing a function rule from a given situation and also using that function rule to analyze a given situation. So at the end of our last lesson, we were looking at Roses Are Red and Flower Power, two flower shops, and we are going to continue looking at those. So Roses Are Red, as a reminder, we have $20 fee plus an additional 75 cents per rose, and Flower Power was a $60 fee plus an additional 50 cents per rose. So let's go ahead and fill out this table the way we did yesterday, and we have 1, 2, and 10 roses. So for Roses Are Red, again, we start with a $20 fee and we're paying 0.75 times our number of roses. So if we're just getting one, it is one rose. And again, just for time's sake, I'm going to tell you what this is. When we type it into our calculator, we would type it in just like that. 20 plus 0.75 times 1, and that's just going to be $20.75. All right, let's continue with Roses Are Red. This time we're doing two flowers. So again, this $20, you're just paying that up front, and then it's 75 cents for each of those two roses. And if we type that in, we should get a $21.50. And then let's jump. We're going to jump all the way up to 10 roses. Again, your format is exactly the same, but this time we're multiplying by 10. And that should give us $27.50. Okay, so what you should notice here is there is a pattern. What are we doing every single time for this? Well, regardless of how many roses we're getting, here it's R, regardless of how many roses we are buying, we are always paying that $20 up front, plus, see how it's a pattern here? You're always paying 75 cents per rose. And in this case, we don't know how many roses we're getting, but we're just going to multiply by however many it is. All right, this means we can write a function rule for Roses Are Red. And we're just going to do this now, and then we'll go ahead and do the same thing for Flower Power. So what this tells us is that the cost, C, of our roses is equal to that $20 plus 0.75 times R. This is called a function rule. Basically, it is representing an equation that can help us find the cost of any roses. Okay, where 20 is our starting fee, and the 0.75 is our cost per rose. All right, so now let's try this again with Flower Power. Okay, and again, Flower Power had a slightly different amount that we're paying. We're going to start with our $60 fee this time, but it's only 50 cents per rose. So 0.50 times, we're still getting one rose. And that one we can probably do in our head, it's just $60.50. All right, we'll do this again. We're going to get two roses this time, but we still have that $60 fee. Plus, it's still 50 cents per rose, but this time we're getting two. 50 cents times 2 is just $1, so this is going to be $61. 10 roses, we're going to up it a little bit. Again, same format. That $60 we're just paying the once, but the 50 cents we're paying for all 10 roses, and this will be $65. And again, let's fill out this pattern that's happening. For Flower Power, we're paying $60 every time, and we're also adding 50 cents for our number of roses, which we do not know, so we're going to put R. So if we come back down, we can write a function rule for that. C equals 60 plus 0.50 times R. Okay, and again, your starting fee is this number we're adding on. Okay, so that 20 or that 60, and the cost per rose is this number that we're multiplying to r. So in this case, the 50 cents is the cost per rows. Okay, so now we can write our dependence statement. Okay, remember what we talked about cost? Cost is always dependent. So what we can say here is the cost depends on the number of roses. Okay, the cost depends on the number of roses. So again, cost will be dependent and number of roses will be independent. Since it's cost depends, cost will be dependent. Which store would be better if you were planning on buying 75 roses, and by how much? Well, now we're going to go ahead and use that function rule, and I'm just going to rewrite what they are. Roses are red, so I'm going to put R was cost equals 20 plus 0.75 R. And then we had flower power. Flower power's function rule was 60, C equals 60 plus 0.50 R. Okay, so now let's see if we can answer this question. Which store would be better if you were planning on buying 75 roses? Well, let's take a look. We're talking about 75 roses. So 75 roses, that's talking about not the cost, C, but R, the number of roses. So what I'm going to do is I am just going to go ahead and plug 75 in for R in each of my equations. So 20 plus 0.75 times my number of roses is 75. Okay, so I'll use my calculator to evaluate this. 20 plus 0.75 times 75, and we get $76.25. So that's the cost of 75 roses if I use roses are red. Now let's use flower power. Okay, it was 60 plus 0.50 times the number of roses is 75. Okay, let's type it in. 60 plus 0.50 times 75, and that's $97.50. All right, so now we should be able to answer the question, which store is better? Well, I would probably say roses are red, right? Because it's definitely cheaper. So I'm going to say roses are red is cheaper by, and let's go ahead and subtract to see what the difference is. So I'm just taking $97.50 minus the $76.25. And it's cheaper by $21.25. Okay, and that's my final answer there. All right, so now, how many roses could you buy for $200 from each store? Which would you choose? This is a little different. $200 is a cost. So what variable do you think we're going to plug it in place of? C or R? Okay, well, if you guessed C, you are correct, and that's because 200 is our cost, just like C is. So let's take our 200, we're going to plug it in place of C, and you're just going to leave the rest of this problem exactly the same. Your R is no longer a 75, it's back to an R. And then this is a type of problem that we were working on in our last unit. I'm just going to write my other equation as well. I'm going to plug my 200 in up here as well for flower power, and then we'll talk about how to solve it. Okay, so what you should remember from our last unit is when we're solving by a variable, we're doing reverse PEMDAS. So here's my line. And what we would need to do first is subtract off our 20. 200 minus 20 is 180. Cancel. Bring down my 0.75 R. And then how would we get the R by itself? Yep, just divide by 0.75 on both sides. Okay, and I don't expect you to be able to do that without a calculator, and I can't do it either, so let's type it in. And we get 240 roses. Okay, make sure you put a roses. So R equals 240 roses. So for 200 bucks, we're getting 240 roses. Now let's see what we would do with the next one. Okay, to solve, again, we'll undo our addition and subtraction first. So we'll subtract our 60 on both sides. That gives us a 140 equals 0.50 R. Okay, and again, to get that R all by itself, we'll have to divide by 0.50 on both sides. R equals, and then we can go ahead and type it in. 140 divided by 0.50. And that's a 280 roses. So I want you to think, if you spent $200, which would you rather get? 240 roses or 280 roses? And my guess is you would say, well, I want this. I want more roses for the same amount of money. So that means in this situation, flower power is better. And I'm going to say flower power gives you 40 more roses. Right? So it's like 40 extra roses for free. Why not? So flower power it is. All right, moving away from flowers, we have one more situation we're going to talk about. And that is some money. So your brother has $525 in savings, but he was not able to find a job this summer. He has been spending $35 each week and is enjoying his summer of leisure. All right, that spending is important because what does that mean is happening to his money? Okay, it means he's losing it. It is decreasing. So let's take a look at what we have here. He starts with $525, right? But he's spending money. So instead of a plus, we are now going to have a minus. How much money is he spending? Well, he's spending $35 each week. And they're saying no weeks have passed yet. So we're just going to multiply by 0. Okay, let's fill out our process column first. All right, week 1, again, he started with $525. He is spending his money, so we're losing it. How much are we losing? $35, and he's been doing this for 1 week. Okay, and again, we will just finish that pattern. 525 minus 35. How long has he been doing this for? 2 weeks. And 525 minus, he's spending $35 and he's done this for 5 weeks. 35 times 0 is just 0, so this is just going to be $525. All right, and just for time's sake, I'll show you how to type 1 into your calculator, but then I'll go ahead and tell you what the rest is. Okay, so again, notice I'm just typing it in the exact same way I wrote it, and this is a 490. Okay, and you can type the other 2 in if you want, but you're going to get a 455 and then a 350. All right, so make a function rule, that means our equation, that models how much money you can save over a given amount of time. Make sure to identify your variables. So what does this mean? Okay, it means we need to say what our letters are. I like to put them in my table. So for number of weeks, how about we use W? Okay, I'm just going to put a W under weeks. And for amount of money, I'm going to put an M for money. All right, now what we are finding is your money, right? That's what we're evaluating. So we're going to start with an M equals, because that's what we're finding, our money. And then just follow your pattern down. We started with 525 each time. We were losing or spending $35 per, and then this number was changing. It represents our number of weeks. So that's a W. All right, that's going to be your function rule. Now your dependent statement, okay, remember what we talked about, money versus time. Money is always dependent. Okay, money is always dependent. And time, I told you, is always independent. So in this case, time is number of weeks. So since you know that, we can write our statement a little more easily. The money, or the amount of money, depends on the number of weeks. Okay, because again, money is dependent. So now if we flip, we just have 2 follow-up questions to answer. How much money will your brother have after 18 weeks? What does this mean? Let me rewrite our function rule. M equals, he started with 525 and we are subtracting 35 per week. Well, again, look at the unit of what you were given, 18 weeks. So is this going in place of W or M? Okay, it should be going in place of W. So we're just going to plug that 18 in, like so, and then we can use our calculator to evaluate it, like so, and uh-oh, we get a negative number. That is bad news. What does that mean? Well, unfortunately, it means your brother is in debt. Okay, it means he owes $105. He has run out of money. Okay, so he's got some debt he's dealing with now. How many weeks have passed if your brother has $245? So this is our last problem. 245. Is that weeks or is that money? Well, it's money, right? So guess where it's going to go? Right in for M. Plug it in. You're going to leave the rest of the function rule exactly the same. So 525 minus 35, and we're back to a W. Okay, and we're going to solve this just like we did in our last unit. I'm going to draw my line. Undo your addition and subtraction first. So I am subtracting the 525 on both sides. And that's going to give us a negative 280 equals cancel. Make sure you don't lose your negative there. And then we'll go ahead and we'll divide by negative 35 on both sides. Okay, so negative 280 divided by negative 35. And that will give us an 8. And we want to make sure we have units. This was W, so it is 8 weeks. All right, there you go. Let me know if you have any questions. Have a great day.